Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 6, Lesson number 2, Zero and Negative Exponents. Before we begin, let me remind you that you can find a copy of the worksheet and a homework assignment that go with this video by clicking on the video's description or by visiting our website at www.emathinstruction.com. Don't forget about those QR codes at the top of every worksheet. Scan those with your smartphone or a tablet and bring you right to the video associated with this lesson. All right, let's begin. So far, we understand or should have a good understanding about what positive integer exponents mean, right? Because they mean repeated multiplication. But let's try to extend this. What does it mean to have an exponent of 0? What does it mean to have an exponent that's a negative integer? All right, that's what we're going to be playing around with today. In Algebra 2, you'll even take a look at what happens when you have when you have exponents that are fractional, like 1/2 or -1/3. But let's take a look. Exercise 1 says we can think of powers of 2, or any number, but let's use 2, powers of 2 as representing multiplication of the number 1 repeatedly. Now I know that seems a little bit weird, but you'll see what I mean. Letter A says fill in the pattern for powers that are not negative. What does this lead you to fill in for 2 to the 0? In other words, 2 to the 4th can be thought of as 1 times 2 times 2 times 2 times 2, right? Whatever, that's, 16. That's not so much important. This is what's important. Right, 2 to the 3rd is 1 times 2 times 2 times 2, right? And that ends up being 8. Now you're probably wondering why I need that 1 in there, but we'll get it, right? So look at this pattern. 2 to the 4th is 1 times 2 times 2 times 2 times 2, which is 16. 2 to the 3rd is 1 times 2 times 2 times 2, which is 8. 1 times 2 times 2, which is 4. 1 times 2, which is 2, or just 1. Right? Think about that. So 2 to the 0 must be equal to 1. In fact, we can extend that and say that any quantity to the 0 will be equal to 1 except for 0. So 0 to the 0 is weird, it's undefined, it doesn't really have a value, and you'll explore that hopefully later on if you take calculus. But 2 to the 0, 5 to the 0, -3 to the 0, those are all equal to 1. Now, what do negative exponents mean? Well, if positive exponents indicate multiplying the number 1 by 2 repeatedly, then negative exponents should indicate division, right? Doesn't that make sense? Positive exponents mean multiplication, negative exponents mean division. So for instance, 2 to the -1 is 1 divided by 2 to the 1st. 2 to the -2 is 1 divided by 2 times 2, or 1 divided by 2 to the 2nd, which is 1/4. 2 to the -3 will be 1 divided by 2 times 2 times 2, which is 1 divided by 2 to the 3rd, or 1/8. 2 to the -4th will be dividing 1 by 2 4 times, or 1 divided by 2 to the 4th, which is 1/16. And it's really kind of cool because it's all about taking the number 1 and either multiplying, in this case by the number 2, if the exponent is positive, or dividing if the exponent is negative. And if the exponent is negative, it tells you how many times you have to divide by. Okay, this is amazingly important because it's really the first time that you're extending the idea of exponents to something other than multiplying, right? So let me clear out the text and then we're going to summarize what we just saw in exercise number 1. All right, here we go. So all of this can be summarized. All right, 0 and negative exponents. 0 exponents, b to the 0 equals 1 as long as b doesn't equal 0. So anything to the 0 power is 1 as long as that thing is not 0. And I'd encourage you to try this on your calculator. Take your calculator and do 5 to the 0. it's going to give you 1. Do 7 to the 0, it's going to give you 1. It probably seems that something to the 0 power should be 0, but it's not. Negative exponents, well, b to the negative n is the same as 1 divided by b to the n. All right? In other words, if I had something like 3 to the negative 5th, that would be the same as 1 divided by 3 to the 5th. Okay? Negative exponents mean division, positive exponents mean multiplication, and 0 exponent just means the number 1. I'm going to clear this out, and then we're going to get a lot of work with this idea, okay? Here we go. Let's play around with the 0 and negative exponents. They take a while to get used to, but they're very critical as we move forward. Exercise number 2. Which of the following is not equivalent to 5 to the minus 2? Well, what we just learned was that 5 to the minus 2 is the same as taking the number 1 and dividing it by 5 squared. Notice how when this thing goes in the denominator, suddenly that power becomes positive. Well, 5 squared is 5 times 5, or 1/25. So clearly this is equivalent. So that's not the one we're looking for, right? It's also equal to 1 over 5 squared. Now, here's the one that it's not equal to, 1/10. If we actually take our calculator out and we ask it, calculator, what's 1 divided by 25? Our calculator is going to tell us 0.04. In fact, if we take our calculator out and we ask it, what is 5 raised to the negative 2? It's going to tell us 0.04, assuming our calculator isn't in some kind of funky fraction mode. Then it would tell us 1/25. So 1/10 is the only one that it's not equivalent to. Okay? So I'm going to clear out the text. Think about this. Pause the video if you need to. Again, I think negative exponents are relatively intuitive. Positive exponents mean multiplication. Negative exponents mean division. All right? 0 exponent, that's the one that's a little tricky. So let's take a look at it in exercise 3. More function notation. If f of x equals 3 times x to the minus 2 plus 2 times x to the 0, then which of the following is the value of f of 2? Show the work that leads to your answer. Remember, exponents always come before multiplication. All right? So what I'd like you to do is pause the video now and see if you can figure out the right answer. All right, let's go through it. So function notation comes up in so many lessons, doesn't it? F of 2. Well, wherever there's an x, I'm going to put in a 2. All right, order of operations, PEMDAS, right? We need to do these exponents first. All right, well, 2 to the minus 2 is going to be the same as 1 divided by 2 to the positive 2. All right, 2 to the 0, on the other hand, is just going to be equal to 1. All right, 1 over 2 squared is 1/4. And of course, 2 times 1 is 2. 3 times 1/4 is, by definition, 3/4. And 2 plus 3/4 is, in this mixed fraction, 2 3/4. Choice 1. So a little bit of fraction work there, as well as work with negative exponents and the 0 exponent. All right? So write down what you need to. Pause the video. Okay, I'm going to clear out the text. Let's keep moving along. All right. So what we're going to do next is develop what is commonly thought of as the third major exponent law. And before we do that, I thought what we would do is make sure that we review the other two. Okay? These exponent laws are going to become increasingly important the longer that you stay in mathematics, the longer you study it, which of course I hope is for every year you stay in school, right? All the way through high school, all the way through college. Take at least one math course at all time. I know that probably sounds like torture to some, but trust me, it just keeps getting better. Right, so the first exponent law, x to the a times x to the b we add the exponents. The second exponent law, if I have, let me give a little example. So if I have x to the second times x to the third, I get x to the fifth. The second exponent law deals with what happens when I have something raised to an exponent raised to another exponent. Then I multiply the two. So if I have x to the fifth, quantity to the third, I get x to the 15th, 3 times 5. So the real question is, what's number 3? Right? Exponent law number 3. Well, we're going to figure that out in just a moment. So I am going to clear out this text. All right, let's figure out our third exponent law, the big 3. All right, exercise 4 says, rewrite each of the following expressions in simplest exponential form. So this is what we did in the last lesson, okay? And I'm going to review how to do that, right? We look at x to the fifth, x to the second, and we break it into 2 fractions. And the first fraction we want to be equal to 1 because we really want it to just go away. So we identify the GCF of these 2 monomials, that's x squared, right? So we write it as x squared divided by x squared, and then this one becomes x cubed divided by 1. That's all equal to 1. That's all equal to x cubed. So x to the fifth divided by x squared is x cubed. You might already have a feeling for what the next exponent property is, but let's keep going. Let's make sure that we don't get mired in the idea or caught in the idea that the base has to be a variable. Here the base is equal to 3, it's numerical. And I can write it as 3 to the fifth divided by 3 to the fifth times 3 to the fifth divided by 1. 3 to the fifth times 3 to the fifth is 3 to the 10th. 3 to the fifth times 1 is 3 to the fifth. That's all equal to 1. That's all equal to 3 to the fifth. So we get 3 to the fifth. So 3 to the 10th divided by 3 to the fifth is 3 to the fifth. All right, fair enough. And in the last problem, if I look at x squared and x to the 8th, I can get an x squared there, an x squared there. I'd have to have an x to the 6th in the numerator to give me that x to the 8th, divided by 1. 1 times x to the 6th equals x to the 6th. All right, so what's that third exponent law? It appears that x to the a divided by x to the b is equal to what? Pause the video now and see what you can do. So in other words, when I divide 2 quantities that have the same base, what do I do with their exponents? All right, well, hopefully what you saw is that I'm always subtracting. Now, subtraction is not commutative. Subtraction is not commutative. So please note, it is always the power of the numerator minus the power of the denominator, right? So in other words, x to the fifth divided by x to the second is x to the 5 minus 2, or x to the third. Likewise, 3 to the 10th divided by 3 to the 5th is 3 to the 10 minus 5, or 3 to the 5th. X to the 8th divided by x to the second is x to the 8 minus 2, or x to the 6th. Isn't that great? A lot of students, very understandably, kind of look at it as, if you take a look at letter A, right? A lot of students think of it as, well, 2x's here are canceling 2x's there, right? That's this, whoops, that's this, and then that's leaving me with x to the third. Here, they kind of think of it as 3 5s are canceling 3 5s up here, leaving me with 3 5s. 2x's canceling 2x's, leaving me with 6x's. It's not a bad way to look at it, but if you get really kind of caught up in that sort of thinking, then what may happen is when you deal with more complicated scenarios, more complicated exponents, that might not help. It might actually hurt you. Regardless, there is our third exponent law. When we divide 2 things with the same base, we subtract the power of the denominator from the power of the numerator. All right, pause the video now, think about what we just did, and then we're going to apply it. All right, let's move on. I'm clearing out the text. Okay, now one of the things that mathematicians like is they want to make sure that when we develop an exponent rule, it makes sense in light of other things that we know. So now what we can do is take a look at this exponent rule in terms of negative exponents and zero exponents. So in exercise 5 it says rewrite each of the following expressions in two ways. One, by using the exponent rule developed in 4D, and two, by using the simplifying techniques that we saw in the last lesson, and, in fact, that we used in the last exercise. So, for instance, right, 2 to the 4th divided by 2 to the 4th. Well, here, let me label them as 1 and 2, right? The exponent law would say, well, we should just subtract those two exponents, so we should get 2 to the 0. All right. On the other hand, we know that 2 to the 4th divided by 2 to the 4th must be equal to 1 because they are the same quantity. And look at that, right? Something to the 0 is equal to 1. All right, let's do one that doesn't turn out to be 0. All right, here we'll get x to the 2nd minus 7. Now watch your subtraction, and that's x to the minus 5th. On the other hand, if we use those simplifying techniques, right, where we do x to the 2nd divided by x to the 2nd times 1 divided by x to the 5th, right, then we just get 1 divided by x to the 5th. And look at that. The exponent law tells us that it's x to the minus 5. The simplifying tells us it's 1 over x to the 5th, and that completely reinforces what we just learned about negative exponents. Let's do one more. All right. 5 to the 6th divided by 5 to the 10th would have to be 5 to the 6 minus 10. Again, watch your negative exponents. That would be 5 to the minus 4. On the other hand, right, if we simplified it, we would say, well, we've got 5 to the 6th divided by 5 to the 6th times 1 divided by 5 to the 4th, right? That'll be 1 times 1 over 5 to the 4th. That doesn't really look like a 4. My apologies. So that's 1 over 5 to the 4th, right? And look at that again, right? Reinforcing the idea that a negative exponent actually means division. So what's important here is the consistency. In other words, that third exponent law that says subtract the power of the denominator from the power of the numerator if the bases are the same, right, completely coincides with what we understand about zero exponents and negative exponents meaning division. Okay? These are some pretty heavy ideas, right? Negative exponents, zero exponents, it's blowing my mind. Wait until you see fractional exponents in Algebra 2. They're awesome. Anyhow, I want to get into that, but I'm not going to. So I'm going to clear out the text, write down what you need to. All right, here we go. Okay, let's do one last problem. So in the coming lessons, we're going to be dealing a lot with what are known as exponential functions, and we won't get into their definitions right now. But here's an example of one. 16 times 2 to the x. And what I'd like to do is I'd like to do a little function notation right now and evaluate each one of those without the calculator. That's actually quite important here. All right, so what I'd like you to do is pause the video right now. You know enough about function notation and about exponents to be able to figure out each one of these three. Even if you're still a little bit confused, I'd like you to take your best shot, and then we'll go through them all, okay? All right, let's do it. So, f of 0. Well, everywhere there's an x, I'm putting in a 0. Now remember, please excuse my dear Aunt Sally, this has to come first. Well, anything to the 0 power is 1. So 16 times 1 gives me 16. F to the 0 is 16. F of 0 is 16. Let's do f of 2. That's going to be 16 times 2 squared. Again, we have to remember to do this first. That's going to be 16 times 4, and that's going to be 64. So f of 2 is 64. But how about f of negative 2? Well, that's going to be 16 times 2 to the minus 2. Again, don't worry about that 16. Maybe put a little times in there. 2 to the minus 2 is going to be 1 over 2 squared. 1 over 2 squared is 1/4. And 16 times 1/4 is 4. All right. So just a little bit of practice with exponents, function notation, zero exponents, negative exponents, all of that. Hopefully you got all three right. But if not, pause the video now, think about what I did, write it down, and then we'll finish up the lesson. All right, let's do it. So today we saw one of the most remarkable things, which was extending our notion of positive integer exponents to a zero exponent and to negative exponents. Negative exponents meaning dividing 1 by whatever quantity is being raised to that exponent, and zero exponents being just equal to 1. Both of these are hard ideas to really wrap your hands around, and it'll probably take a few years of practice with them. Not constant practice, but seeing them in a few different courses to really have them down solid. For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking.